This article was updated at 5:44 p.m. EDT to indicate that a coronal mass ejection was observed coming from the site of the solar flare. Early this morning, September 6, the Sun released two powerful solar flares. The second was the most powerful in more than a decade. At 5:10 a.m. EDT 0910 GMT, an X-class solar flare, the most powerful sunstorm category, blasted from a large sunspot on the Sun's surface. That flare was the strongest since 2015, at X 2.2, but it was dwarfed just 3 hours later, at 8:02 a.m. EDT 12:02 GMT, by an X 9.3 flare, according to the National Oceanic and Atmospheric Administration's Space Weather Prediction Center (SWPC). The last X9 flare occurred in 2006, coming in at X 9.0. According to SWPC, the flares resulted in radio blackouts. High-frequency radio experienced a wide area of blackouts, loss of contact for up to an hour over the sunlit side of Earth, and low-frequency communication, used in navigation, was degraded for an hour. The Sun's worst solar storms in history. A massive X 9.3 class solar flare blasted from the Sun at 8:02 a.m. EDT 12:02 GMT. Credits a day. Steve Splita solar flares occur when the Sun's magnetic field, which creates the dark sunspots on the star's surface, twists up and reconnects, blasting energy outward and superheating the solar surface. X-class solar flares can cause radiation storms in Earth's upper atmosphere and trigger radio blackouts, as happened earlier this morning. During large solar flares, the Sun can also sling a cloud of energetic plasma from its body, an event called a coronal mass ejection (CME). It was accompanied by radio emissions that suggest there's a potential for a CME, SWPC space scientist Rob Steenberg told Space.com. However, we have to wait until we get some coronagraph imagery that would capture that event for a definitive answer. The Orbiting Solar and Heliospheric Observatory, a joint project between NASA and the European Space Agency, later provided that answer when it picked up the coronal mass ejection from the event, although according to SpaceWeather.com, NOAA analysts are still modeling its trajectory to see whether it is directed toward Earth. Decided the current huge sunspot regions were worthy of breaking out the old trusty orthograph orthometer to biz their spatial scale. Picked out Twitter.com Ski52 Toted, Carl Badams at Sungrazer Comet September 5, 2017. The sunspot responsible for this morning's flares, active region 2673, is the smaller of two massive spots on the Sun's surface, at only 7 Earths wide by 9 Earths tall, according to astrophysicist Carl Badams. Yesterday, that same sunspot emitted an M-class solar flare, 1/10 the size of an X-class flare, leading to a coronal mass ejection aimed toward Earth that could cause auroras tonight as far south as Ohio and Indiana. NASA's Solar Dynamics Observatory captured this view of a mid-level solar flare on the Sun at 4:33 p.m. EDT on Monday, September 4. Credit NASASDO. Credit Carl Tate, Space.com contributor. If aimed toward Earth, the CME from these latest flares could lead to even more spectacular auroras, but could also damage satellites, communications and power systems. That cloud of charged plasma would arrive within 1 to 3 or 4 days, Steenberg said, although CMEs triggered by energetic flares generally come quickly. The surge of activity might seem surprising, as the Sun is approaching its solar minimum, with the lowest levels of activity in its 11-year cycle. We are heading towards solar minimum, but the interesting thing about that is you can still have events, they're just not as frequent, Steenberg said. We're not having X-flares every day for a week. For instance, the activity is less frequent, but no less potentially strong. These kind of events are just part of living with a star, Steenberg added. Editor's note: this article was originally posted at 10:55 a.m. EDT. Email Sarah Lewin at lewin@space.com or follow her at Sarah Explains. Follow us at space.com, Facebook and Google. Original article on space.com.